Okay, I've got us at 2:31, so I think it's a good time to get started. Hello, everybody. Hello. Welcome to Science Track. It is good to see you again. I'm very happy to be back. It is lovely to see you all. Just want to make sure, let everyone know, not to start the presentation until everyone is properly masked. It appears that everyone is. We do have extra masks up here if anyone needs one. I also like to point out that Science Track charity is Big Brothers and Big Sisters. America, their donation can is right here for your hard-earned money if you so choose. Thank you. My name is Jeff Hubbs. I'm a consultant dealing in issues of energy systems transition and climate change. I'm currently a consultant working for Georgia Tech's School of Public Policy, the Drawdown Georgia project, which is whose mission is to define ways by which the state of Georgia can reduce its greenhouse gas emissions. I changed into this line of work out of information technology, which I worked in for 25 years. I worked for the Air Force and for the U.S. Department of Energy, went to private sector IT after that. And in 2011, I decided to go work on this stuff. And in the course of so doing, one of the things that that helped me frame stuff in my head is how humanity uses resources. Wars are fought over resources, which is no surprise. Wars are also won on resources and lost on resources. Nazi Germany rose on the acquisition of resources. One of the reasons they invaded France was to get at those aircraft and automobile manufacturing plants, which at the time were some of the best in the world. It's also how come they were so interested in North Africa. What's the big deal about North Africa? You remember what those countries are and how much oil they had? Part of the problem of trying to expand all over Europe and the rest of the world was you needed to have a lot of resources to do it, especially fuel. That's why the names of the processes to convert biomass into liquid fuels that you can use in engines have German names. Because they were fixated on this thing of how to expand their resources. And that's a big reason why Nazi Germany fell, is they simply could not keep up. You can't have that kind of expansion and control without the resources to back it up. So when we look at the world we live in today, it's all about allocation of resources. How do we regulate what we create? What laws do we need and regulations do we need? We have to decide what is important to us. How do we protect ourselves and each other? All across the world, cultures have a baked-in relationship with the resources under their control. In Western civilization, we recognize what some of these resources are: energy, raw materials, food sources, fresh water, manufactured products, and even information. Much of our lives revolve around obtaining and consuming resources, and even producing or providing resources for others. We're accustomed to certain allocations of resources, and within our lifetimes, we don't perceive those allocations as having really changed very much. But on longer timescales, these allocations have changed a lot. Looking just at world energy consumption over time, we see that sometime in the mid-19th century, what we call the Industrial Revolution, our civilization began consuming energy at an accelerating rate. But if we look at even longer timescales, back into the past, we find that for over 99% of human history, we lived as low-density foragers or farmers in communities of no more than a few dozen individuals. A human labor-based society, where that's your prime mover, is just what you can do with your arms, your legs, and your mind, can only generate about 1/20th of a horsepower per person, about 37 watts. If we take the data in the previous graph and divide it by world population, we see a rise over the same period. So this graph is a measurement of how much energy each person consumed on average. So if you think the world looks different today than it did when the character of Sherlock Holmes was first written, You can see why right there. There's a massive increase in per capita energy consumption, most of it powered by burning fossil fuels. Of course, these figures paper over the fact that per capita energy use is highly variable around the world. We can see that the United States is among the most energy-intensive countries per capita. That end of the graph, the big end of the graph to the left, is populated by the cold countries and the ones that extract oil. Extraction of oil is a very energy-intensive activity. The US looks to be about 4 times the world average. While at the other end of the chart, you can recognize those as being some of the most impoverished places on Earth. When people go to Europe, Switzerland, Austria, away from the big cities in Germany or France, and they look at the little villages and think, oh, how quaint all of this is. Well, what you're really seeing is you're seeing how people live when their per capita energy consumption is a lot lower than what you're used to here. And in Europe, it's roughly about a third. Going back to this chart, you can look back in the past and see what our historical consumption has been like. But what if we could turn the telescope of time around and see what energy and other resources would be like in the future? Will this rise continue indefinitely, or will it follow some other trajectory? Now, every year, I work with this system, by the way. The U.S. Department of Energy's Energy Information Agency tries to do just that, out to a roughly 30 or 40 year time horizon. To prepare that agency's annual energy outlook, they use what's called the National Energy Modeling System. It's a highly complex software system that computes energy consumption and costs. But one of the components of that system is a macroeconomic model of the United States. What we do is we make changes to the assumptions of that model in the laboratory that I work in to come up with alternate futures based on the changes that we make either to the inputs or the code that comprises the model. There are no assurances built into that system's predictions. And if you just eyeball that chart, there's nothing predicted out in time that's as pervasively disruptive as, well, say, the coronavirus pandemic, or even the Great Recession of 2008 and 2009, which is by far the worst of the post-war recessions, at least until we get through baking the numbers of the one caused by the pandemic. Or the kind of resource consumption growth that characterized the rebuilding that kicked off Europe and Japan, or the expansion of the U.S. economy after World War II. So it stands to reason the future will be crunchy, if only because we observe the past has been crunchy. Software models like this aren't sophisticated enough to tell us when and what the upheavals will be. So, where does our society turn when we want to contemplate what's going on in the future? Well, the late film critic Gene Siskel used to refer to his job as covering the national dream beat, his implication being that our movies are one way by which our society dreams. Our science fiction, then, can be thought of a way for us to dream about our future. It turns out that the futures envisioned by some of our science fiction movies and TV shows contemplate profound resource abundances or resource poverty. I'm going to talk first about resource abundance and some of the creative thought that went into it. Mr. Gene Roddenberry is an established Hollywood screenwriter, initially known for his work on a dramatic series called The Lieutenant. Its protagonist was a U.S. Marine JAG officer, a military attorney. Roddenberry wrote and produced one episode called To Set It Right, and its theme centered on racism. The plot so concerned Pentagon officials. The series was made with the cooperation of the Pentagon, who provided locations, props, and even real live Marines as extras. The Pentagon officials were so concerned by the story, which was actually even watered down in pre-production, that the Pentagon contacted NBC and complained. NBC refused to air the episode, and they even refused to pay the production company. This angered Roddenberry so much that he decided to strike out into a whole nother genre. that would enable him to produce stories about thorny social issues more obliquely. He envisioned a spacefaring ship and its crew set roughly 300 years in the future and named his show Star Trek. What Roddenberry could not have possibly foreseen was that his wagon train to the stars, his Horatio Hornblower in space, would spawn 6 television series and 12 feature films over 47 years. I guess now it's more than 6, isn't it? Is it 28? A bunch. Becoming the most extensive science fiction franchise in American popular culture. Although the ships and the characters would change, the story universe remains essentially the same. For the protagonists of Star Trek to seek out new life and new civilizations, the action required them to travel, quickly. To avoid being too much at odds with real physics, Roddenberry proposed that in order for their ship, the Enterprise, to cover interstellar distances in a practical amount of time, superluminal travel, faster than light, had been developed and had become routine. Now, superluminal travel is not part of current understanding of real physics, but it's a common story conceit used all over science fiction. Without it, crews would cycle through many generations before reaching even the closest stars. In Star Trek, superluminal travel requires a lot of energy, so much that it requires a matter-antimatter reaction to create it. Now, that's not a make-believe process, it's real. It was known to physicists in the 1960s, and it's described by Albert Einstein's famous E=mc² equation. E there is energy, m is the combined mass of the reacted matter and antimatter, and c is the speed of light. Now, where the idea becomes fantastical, what makes it science fiction, is that while there's almost no antimatter left in the universe in its current state, being able to amass any macroscopic amount of it is unthinkable. Although if you could, like Star Trek's people do, you'd have to be exceptionally careful with it. If by magic you could create an antimatter nickel coin, I've sort of reversed the color on the antimatter cone, but if there were a real one, it would look just like a nickel. There's nothing really weird about it. It has the same chemical and physical properties as matter, and if you combined it with a nickel coin, such that the mass of both coins would be converted completely into energy, you plug the numbers into Einstein's equation and see the amount of energy released would be stupendous, on the order of that released by a single peacekeeper nuclear warhead, which has about 25 times the yield of the little boy weapon that was detonated over Hiroshima in 1945. Yet through some contemporarily unfathomable technology, Star Trek's vessels perform this reaction in a controlled way, using the energy to warp space-time in the region around the ship such that the ship can reach destinations thousands of light years away in just a few days, as experienced by the occupants of the ships. Star Trek's Enterprise is far from unique or novel. It's said to be a Constitution-class ship, which implies multiple copies of ships in multiple generations. And the Enterprise is the flagship of Starfleet, which is engaged in exploration and, when necessary, humanitarian and military functions on behalf of a united federation of planets, planets that are connected by this means of travel. Now, the Federation planets and the space they inhabit cover in the story universe about a quarter of the galaxy and are home to many humanoid species. And external to the Federation are various other unaffiliated and antagonistic civilizations, many of whom are also warp capable. Now, in Star Trek, Roddenberry's core organizing principle for the stories was optimism, that the differences, conflicting motivations, and prejudices of Earth and other planets' inhabitants would eventually be overcome in time, albeit perhaps messily and bloodily. Allusions are made to a World War III in 21st century Earth. One episode reveals a flirtation with eugenics on Earth that spawned a tyrannical Ubermensch who ruled a quarter of the planet until he was deposed. Despite all the setbacks, technological innovation on Earth and on other planets has continued since our time to make interstellar travel look like cruise ship travel, and to make the practice of medicine look like the miracles of Jesus. But the characteristic of the Star Trek universe that we're especially concerned with here is the widespread ability to marshal incredible amounts of energy, to the extent the economy of the Federation civilization collapsed. Now, in this sense, when I say collapse, what I mean is the need for an economy was dispensed with. Offhanded references to an antiquated system of cash exchange exist, and colorful greed-motivated characters such as the gamesters of Triskelion, triple peddler Cyrano Jones, hapless megalomaniac Harry Mudd, and the entire Ferengi species for whom commerce and finance aren't like a religion, they are a religion. And they're all regarded by our protagonists as quaintly petty troublemakers. At times, Star Trek characters are explicit about their lack of an economy. After sticking a marine biologist with a check after dinner in 1980s San Francisco in Star Trek IV: The Voyage Home, she snaps at an empty-pocketed James Kirk. "Don't tell me they don't use money in the 23rd century." And Kirk lamely responds, "Well, we don't." In the 1996 film Star Trek First Contact, Enterprise Captain Jean-Luc Picard explains it to a woman from the 21st century who asks him how much it costs to build the Enterprise. He says, "The economics of the future is somewhat different. You see, money doesn't exist in the 24th century. The acquisition of wealth is no longer the driving force in our lives. We work to better ourselves and the rest of humanity." So our protagonists appear to have evolved past material want, for the amounts of resources they control would have obsoleted the novelty of and the status associated with the acquisition and display of material possessions. On reflection, perhaps Starfleet's size is more constrained by the availability of officers like a Kirk or a Picard than by the sheer number of ships they can build. So why would Gene Roddenberry be so optimistic? Why would he have come up with stories that would propose that this incredibly resource-rich future would be laying out in front of us? Well, he was a former military man. He knew that world wars would be won with the involved dictatorships fallen and the democracies victorious. When the first draft of the first Star Trek pilot, The Cage, was completed in September 1964, the United States and the Soviet Union were well into their manned spaceflight programs. The Mercury program had successfully flown 7 astronauts on suborbital and orbital missions, and the Soviets had flown their first woman in space, Valentina Tereshkova. Electrical power generation by nuclear reactor was in a nascent stage in both countries. About a decade earlier, then chairman of the U.S. Atomic Energy Commission, Lewis Strauss, declared in a speech that, quote, "Our children will enjoy in their homes electrical energy too cheap to meter," unquote. By the time the first episode aired, the U.S. had completed the first soft lunar landing by an unmanned probe, and fully electronic digital desktop calculators were available on the market. What with other scientific and technical advances of the day, and the dawning of the civil rights movement meant to address socioeconomic inequities left over from the Reconstruction era, a sense of optimism would have been hard to not develop. Why shouldn't these developments proceed naturally to antimatter-powered starships piloted by a mixed race, gender, and species crew with no need for money 300 years in the future? Subsequent Star Trek series ran continuously from 1987 to 2005 and then picked up again in just the last few years. And the core concept of resource-abundant civilizations remain consistent. Here's another abundant civilization, a little bit closer to home in time. The action of the 1968 film 2001: A Space Odyssey takes place against a backdrop of resource abundance set a mere 40 years in the future. To us, 20 years in the past. Although the story revolves around the fantastical notion of starkly inhuman extraterrestrial intelligence, they never depict aliens, only a series of featureless black rectangular objects. The imagined human experience is an extrapolation of industrial, scientific, technological, and commercial progress viewed from a 1960s perspective. In the second of the film's 4 acts, the audience is given a glimpse into life in the year 1999. A winged spacecraft with Pan American Airlines livery, of course Pan American is gone, long gone. It's docking with a large rotating space station in Earth orbit. We can see that one of the space station's 2 rings is still under construction. It's a work in progress. As the action transfers to the station's interior, it looks like a clean, stylish, and functional airport. It's a far cry from the drab, cluttered, and haphazard interiors of real space stations that we would see only just a few years later. That's the interior of Skylab. We see signs for Howard Johnson's hotel chain and the Bell system, forerunner of AT&T, the latter of which is shown prominently as a character places a video phone call to wish his daughter a happy birthday, all for the cost of $1.70. The same character takes a transport ship from the station to a permanent base on the moon, where he gives a briefing to a group of men and women in what we recognize as business attire. This setting, with its flags mounted on poles and the typical accoutrements of formal meetings such as water pitchers, an official photographer, it'd be fully familiar to a 1960s audience, with the only real tip-off that this is taking place 40 years in the future being the full wall lighting, the oddly cut business suits, and of course the topic of discussion. The film's third act shows an interplanetary craft, the Discovery, longer than a football field, with some of her crew held in a state of suspended animation and accompanied by a wholly intelligent computer, the HAL 9000, bound for Jupiter. In the crew compartment is a centrifuge. Here, astronaut Frank Poole is taking a jog around its periphery. The Discovery contains 3 pods suitable for the crew to perform tasks outside the ship. Now, this shorter time horizon, less distant technology, and the vastly reduced theater of operations all make 2001 a more believable and imminent resource-rich environment. Remember that when this movie was made, commercial air travel had existed for about 40 years. The first commercially available IBM computer was about 15 years previous. Manned space flight, about 7 years. So in a resource-abundant story universe, the audience is meant to react with awe and wonder. We, Westerners, tend to interpret the degree to which an individual or organization is able to consume or convert energy as a measure of its prestige, its potency. But causing awe and wonder does not constitute drama. And this poses a challenge for story writers. Now, author and Star Trek writer David Gerrold characterized a successful dramatic presentation as being a broad-based format about an interesting individual or group of individuals whose responsibilities force them into unusual situations and confrontations, requiring decisive and positive action on the part of the protagonist and his cohorts. The dramatic potential of a resource-rich scenario in and of itself is weak. For people who are simply free to act out their profligacy, aren't very interesting, like Richie Rich here. But if abundance facilitates the other elements, as Gerald described, a successful drama can be constructed. Therefore, dramatic conflicts in Star Trek tend to center on issues of individuals' power and control, honor, revenge, prejudice, racial hatreds, freedom, sacrifice, acceptance, friendship, or various ethical or moral quandaries. The limitations they face, therefore, tend to be things they can't simply power out of. We're told that Enterprise can outrun most anything in the galaxy and can obliterate an entire planet's surface. But to make good stories, opening fire or warping away can never be allowed to be the extent of a problem solution, nor its best obvious solution. In 2001, being able to take a shirt-sleeve ride to a moon base makes for fascinating visuals, but it's not much of a plot. On the other hand, exploring the moon, discovering an unusual magnetic field in the bottom of a crater, excavating a mysterious black rectangle that emits a powerful radio signal toward Jupiter the first time sunlight hits it, being sent to Jupiter without knowing the mission's actual intent is to investigate the signal's destination such that the computer tries to kill you because it's decided you're a threat to the mission, that's a plot that ultimately hinges on a conflict rooted in deceit and the danger posed by directing an inherently truthful machine to lie. Or in Star Trek II, The Wrath of Khan, the franchise's most recognizable and beloved character sacrifices himself to save his shipmates from the detonation of a misappropriated terraforming device. A key plot point is that the self-same, immensely powerful yet portable device built to be a planet creator by some would be even more desired by others as a planet destroyer. And not all putative futures in American science fiction have been based on a fundamental optimism. A great many dystopias have been presented in the genre, such as THX 1138, A Clockwork Orange, Blade Runner, and Max Headroom 20 Minutes into the Future. But certain of the dystopias have a key characteristic very much opposite that of Star Trek or 2001. Their settings and the motivations that guide the characters are based on a chronic lack of resources. One film that vividly depicts resource poverty is 1973's Soylent Green. The film opens with a pastiche of still images presented Ken Burns style, starting with bucolic sepia-toned Americana scenes while a gentle gospel-tinged piano plays in the background. As the music becomes edgier and more dissonant, the pastoral imagery gives way to busy cities, giant lots full of identical cars, imposing mounds of garbage, settling finally on a long shot of a monochrome, smog-choked New York City, which we learn has a population of 40 million in 2022, with 20 million unemployed in Manhattan alone. For the most part, Soylent Green is a straightforward police procedural, not unlike 1967's In the Heat of the Night or 1971's The French Connection. But the constant subtext girding the action in this film at all times is crushing resource poverty for the vast majority of people. The beginning of the film shows William Simonson, the wealthy director of the Soylent Corporation, being clubbed to death in his apartment by an intruder. Soylent, we learn, controls half the world's food supply. Robert Thorne is a police detective who moonlights in homicide when he's not on riot control duty. He and his elderly roommate, Saul, live in a small, grimy walk-up apartment. It's lit using a rack of batteries charged by a stationary bicycle fitted with a generator that Saul is pedaling there. Thorne is assigned to investigate the Simonson murder. Thorne's and Saul's building is full of homeless people splayed out in the stairwells, and the streets are littered with immobilized cars being used for shelters. Beef is such a rare commodity that most people never see any, and the presence of a jar of strawberry jam and a woman in a silk robe in Simonson's security guard's apartment is enough to tip off Thorne that the guard is living well beyond his means. Lines form out in the streets for water and food. Here we see bins full of Soylent Yellow and the company's new product, Soylent Green, which we are told is made from high-energy plankton. We note that Simonson's body is bagged up by a crew and carted away in a garbage truck as Thorne investigates the murder scene. Still somewhat in shock at the brutal slaying, Simonson's concubine, Cheryl, mentions to the security guard that she remembered that when she was a little girl, there was a ceremony when her grandmother died, suggesting a significant shift in the cultural perception of death in as little as a single generation. Thorne is a bit of an opportunist. Apparently soap is a high luxury, and he gathers up a bar along with some booze, food, and other items in a pillowcase and hitches a ride with the body disposal crew back to his apartment. Knowing that Saul was a former professor, he says a respected man at one point in the film, Thorne also brought home a large 2-volume book, an oceanographic report produced by Soylent, covering the years 2015 to 2019. This excites Saul to no end. He still reveres books and has many stored in the apartment. Saul brings the book to a group of elderly men and women known as the Exchange to have them evaluate the book's contents. Later, Saul enters what we realize is a euthanasia clinic. He's led into a chamber with a bed and an observation booth off to one side. Back at their apartment, Thorne finds what he realizes is a suicide note from Saul. Thorne races through the night to the clinic to try to intervene, but by the time he arrives, Saul has ingested the poison to end his own life. The walls of the suicide chamber form a giant projection screen, and images of the Earth's natural beauty vividly surround Saul in a dazzling display that astonishes both men, but especially Thorne, who well may have never seen such scenes in his life. Activating an intercom between the suicide chamber and the control room, he helplessly watches the dying Saul on the bed. He listens intently through an earphone as Saul speaks to him. We, the audience, can't hear everything Saul says, but we can clearly hear him say, "You have to prove it." After Saul quietly passes away, Thorne sneaks outside and finds where the bodies are taken. There are a lot of them, and they're being loaded into garbage trucks just like Simonson was. Thorne stows away atop one of the trucks and rides it into what appears to be some sort of industrial facility. Once inside, the trucks are opened. The wrapped corpses are pushed out like cordwood. The facility seems mostly deserted, so Thorne presses further inside to investigate. He sees the bodies being shuttled around the factory on conveyor belts. As he explores further, Thorne realizes there's some sort of process involving the bodies as they're being dropped into a pool of liquid off conveyor belts. Finally, we see it before Thorne sees it. A conveyor belt carrying green wafers. What the exchange had told Saul, and what Saul had told Thorne in the euthanasia clinic, and what Simonson knew, leading him to not even resist his killer, was that the oceanographic report revealed that the plankton population had crashed. Soylent Green is people. Through the course of the film, we're told that the New York City of 2022 is hot all the time, and that according to Sherrill, cold is something that winter used to be. Faced with the plankton crash caused by the changing climate, Soylent turned to a plentiful and readily available source of nutrients to develop the new addition to its product line. This chart shows the fossil fuel inputs that go into food productions in the United States. Now imagine how those energy inputs would change if food products could be transported at high densities, didn't have to be refrigerated or prepared, and for which the primary component walks into centralized processing facilities voluntarily on its own 2 feet. Looking beyond the film's central conceit of industrially sanitized and packaged cannibalism, the privation shown in Soylent Green can be discerned as not constant, but accelerating, even as the status quo impoverishment level was being outwardly maintained. All the public sees is a new and improved food wafer, whereas what's really occurring behind the scenes is the collapse of the planet's ecosystem. Soylent Green dramatizes the human race well into overshoot. Other science fiction releases have played the privation card from a variety of angles. In Logan's Run, a seeming utopia is made sustainable by terminating its citizens at age 30. The hero of 1972's Silent Running mutinies in order to save the last forest in a dome floating beyond the orbit of Saturn. The Mad Max series features characters in a lawless post-apocalyptic desert landscape who battle each other for food and fuel. In an especially severe, albeit geophysically unrealistic vision, the Earth of Waterworld is entirely covered in water after its ice caps have melted. The survivors boat between floating villages trading precious commodities like dirt and lemons. Resource-looting renegades called smokers, which suggests that the nicotine addicts had at some point seized the high ground, literally. They terrorized the planet-wide ocean in an ore-driven, barnacle-covered Exxon Valdez. The Hunger Games is set some 275 years after a series of global catastrophes ends what we now know as business as usual. The nation-state of Panem on the North American continent divided its territory into a capital and several districts. Katniss Everdeen lives in District 12. Its primary economic activity is coal mining. While capital dwellers pursue an archly decadent and hyper-technological lifestyle, District 12 residents hover near the edge of starvation among what we would recognize as 19th century accommodations. Katniss and a young man named Peeta are pitted against tributes from the other districts in an annual death match in which the combatants are given limited food and supplies. When Katniss and Peeta are the last competitors left alive, they turn the tables on the game's masters by both agreeing to commit suicide with poison berries and leave the games with no victor to celebrate. Now, plots in resource-poor films tend to resolve in one of 3 ways. The protagonist can prevail against an antagonist who works within or controls the privation system. Examples might be The Road Warrior and Waterworld. The protagonist can escape directly, like in Logan's Run, or by proxy, like in Silent Running. The protagonist can crash the system by revealing a terrible secret, like Soylent Green, or causing the system's masters to lose face, like in the Hunger Games. I developed a timeline of American science fiction films from 1949 to 2012. Most films are what I call resource orthogonal. In other words, their resource availability doesn't really figure into the story. Now, I've marked the films that present as resource poor with a red tag, and the films that present as resource rich with a green tag. Is that what I meant? Yeah, okay.
Yeah.
My notes are screwed up. And what I did is I then, imagine a little slider going from one side of that to the other, from the past toward the present, and counting up by +1 if it hits a green tag film, and adding -1 if it hits a red tag. I wanted to see if there was a trend. So I produced this graph. And down below is a 5-year window moving sum to better disclose trends. Like the value of the graph on the bottom in a given year is the sum of that year and the 4 years prior. So this graph can be thought of as an index of the resource availability zeitgeist in American science fiction film as perceived by the audience. This index went on the upswing in post-war America and began to collapse in the early 1970s. Authors named Meadows, and Randers published a book called The Limits to Growth in 1972. And the Arab oil embargo began in 1973, which gave a new generation of Americans its first look at a disrupted national energy supply. The index reverted back to resource-rich during the 1980s, remained largely so through the 1990s, and turned sharply resource-poor beginning in the early 2000s. We appear to be in a resource-poor film era. I hope to compare this index to other measures looking for some connection that I could write about. And I didn't have to look for long. The first thing I tried was crude oil price. As you can see, the resource zeitgeist index and crude oil price appear to inversely track each other. Here's another graph I overlaid onto it. Annual change in the average retail price of electricity. It shows a similar fluctuation along with the resource zeitgeist in the films. So if our resource-abundant films are a wish, our resource-impoverished films are a warning. My key findings suggest that our society heeds the warnings of real resource scarcity and plays out scenarios on screen in a kind of collective imagination. At one point in Soylent Green, Saul asks one of the elders of the exchange, "Why are they doing this?" And very calmly she answers, "Because it's easier. I think expedient is the word." So as we dream these dreams in our movies and TV shows, we must decide if expedience is what we want most of all. We have to prioritize that expedience along with the rest of our values. Thank you very much for your time and attention. I'll be happy to entertain any questions.